In the first presentation, Balázs Molnár will provide a general overview of the most important AWS services that do the heavy lifting and solve most of the problems businesses face in this domain. Please welcome on stage Balázs Molnár from SnapSoft.
So, good evening, everybody. I'm Balázs Molnár. I work as a cloud architect at SnapSoft Ltd. And today I will be talking about how to build machine learning models without having our own server park, without having our own infrastructure. In other words, how to build AI in the cloud. As I'm specialized on Amazon Web Services, which is the biggest public cloud provider, the main focus will be on the AWS services and tools that can do the heavy lifting for us when we solve problems with machine learning. As I mentioned before, I'm not a data scientist, but when I did the preparation work for this conference, I asked my experienced data scientist colleagues about the difference between machine learning and AI. And finally they said, oh, Balázs, it is easy. If it's written in Python, then it's probably machine learning. But if it's written in PowerPoint, then it's probably AI. So based on this definition, I didn't dare changing the title, but you will see that behind the scenes, we will solve today like a real-world problem with machine learning. So what's the agenda for today? As far as I know, most of us here is or will be an engineer soon, and but engineers love solving problems. So I'm going to define one, and we will solve this problem with machine learning. And by doing so, we are going to walk through the whole the whole journey of the machine learning workflow. So first, we are going to talk about how to collect data, how to ship this data to the cloud. So we are going to do some data engineering, and then we are going to talk about how to prepare this data for machine learning training. So we will do some feature engineering, and finally we will do the modeling. So we will train an actual algorithm, and we will deploy this algorithm to a production-like environment and do some inference. So use this model. So let's do the example business problem. So let's imagine that we run a web shop that sells shoes. Let's call it Snapshoes. This Snapshoes thankfully has a bunch of customers, and we sell thousands of different products. So we've got some feedbacks from our customers that they would like to take a picture of a product that they saw like in an offline shop. And they know that we also sell, so they want to take a picture of this product, upload it to our servers, or just send it to us, and they expect us to redirect them to the product page so they can purchase this product on our website. So to translate it to machine learning, we need an algorithm that can recognize our own products on random pictures. So some of you may be wondering what is this amazing pair of shoes might be. And perhaps even more if you would like to know what the product ID of this shoe is. Well, I've got some good news for them. By the end of this presentation, we will have a trained model that can recognize this particular amazing pair of shoes on a picture. So let's see how to do that. First, we need data. So in practice, data scientists spend a great bit of their time on just collecting and processing data for training. In fact, it is sometimes a larger effort than actually doing the machine learning training. The challenge here is to find a place, get the data to this place, transform the data in a shape that it needs to be. We might need to deal with real-time processing, massive scale, heterogeneous data sources, or obviously strict security requirements. So let's see how can AWS help us, and how can AWS do the heavy lifting when it comes to data engineering. So we wanted to recognize products on pictures, and at least we wanted to enable our customers to do so. So we need a bunch of pictures of our products. Somehow we need to ship it to AWS, and we also need to enable our customers to upload their own pictures to AWS so we can redirect them to the product page. So for the first problem, we can go like old school and use FTP or SFTP or one of these protocols. And on AWS to do so, we can use many services called AWS Transfer or the AWS Transfer family. Or what we can also do is just simply use the AWS portal, AWS console, or the AWS command line interface, so AWS CLI, to upload these pictures. There are a bunch of other options out there. I just wanted to highlight these two for now. And as of the customer image upload, what we could do is we could just simply spin up an AWS API gateway and provision a serverless stack behind this API gateway, and that can handle the image uploads. So for those who would like to learn a bit more about serverless stack, I recommend checking back the previous year's Simonyi Conference, where my dear colleague Adrian Mezei had an excellent presentation about the serverless stack on AWS, why is it good to use that, and how can it help to us. Although it wasn't stated in the problem, but we might want to enable our customers to use their mobile app and their camera to show us the product that they expect us to recognize, and so we could redirect them real time. If we wanted to do so, it's not a simple problem, but thankfully on AWS there is a solution for this as well, called Kinesis Video Stream. So we can utilize this service to process video real time and recognize objects on video real time. Okay, so now we know how to upload our data to our AWS. Where should we upload this? We need a storage solution. So thankfully, we are on AWS, and AWS offers a wide variety of storage solutions, starting from the low-level elastic block storages, elastic file systems, moving forward with object source, and AWS offers also quite a few managed database services. For today, I'm going to focus on the service that the data scientists most frequently use for machine learning, and this is the simple storage service, as known as S3. So S3 is a highly available, highly reusable object store. This is actually one of AWS's first service, so it is pretty mature. It gives us theoretically infinite storage space. We also don't really need to worry about storage capacity. It is elastic, so if we need more, they give us more without us explicitly needed to ask them. And thanks for the object life cycles, we can also save money. And I almost forgot to mention, it has quite a few settings to fine-tune the access permissions, so it is really good for security purposes as well. If we run maybe a bigger corporate where we have multiple machine learning teams that want to use the same data set, then we could go with some sort of advanced service. So we could use the SageMaker feature store, which is a purpose-built service for data scientists to do machine learning training and inference. But for today, we are going to go with AWS console and CLI, and we are going to upload that data to Amazon S3. So let's see how would it look like in practice. Once we have an AWS account, we can just log in and navigate to Amazon S3 page. There is a create a bucket button where we only need to specify the name, which must be globally unique, by the way. In our case, I specified Snapshoes, obviously. And if we have the bucket, then we can create a folder. For the folder, I choose to use the product ID. We're going to use this folder or this information later when we do the labeling. Just bear with me. And then once we have the folder, then we can upload the pictures of the pair of shoes that we would like to recognize. In our case, I uploaded 24 pictures. So data engineering shipped out data in a place where it needs to be. But unfortunately, this data is not perfect. It's not ready yet for training that we are planning to do with that. We are planning to do some sort of supervised training where we not just only need the pictures of the products, but we also need to know what exact product is on the picture. And we also would like to know which part of the picture has the product in it. So let's see what can AWS do for us to resolve this problem. So if we had thousands of pictures, and we don't really want to spend our time on manually drawing rectangles around our products in these pictures, we can ask AWS to do it for us. In this case, we can submit our pictures to SageMaker Ground Truth and label generation, and AWS will use its own human workforce and also some image recognition to do the labeling for us. In this case, we will get back the pictures and the labels on them. I uploaded only 24 pictures, so for me, it's not a big pain to do this rectangle drawation or this labeling myself. So I'm going to go with manual label creation today. Let's see how can we do that. So we were already logged into the AWS console. Now let's choose another service to do that. This service is called Amazon Recognition Custom Labels. Once we selected this service, make sure to select the same region as we used for the S3 bucket. But otherwise, it is pretty straightforward. So the first step is to create a project. Again, my project wears the Snapshoes name. And once we have the project, we can easily create a data set to pull our pictures in. Once we clicked on Create Dataset, we have 4 options to choose from. Number 1, we can use one of the S3 buckets. The second one is just to upload it from our machine or our computer. The third one is to pull data from other data sets. And the fourth is to use SageMaker Ground Truth. For now, we will go with our new S3 bucket. So we will select the first option, specify the name of the bucket, and to use the folder name as an image level label, we are going to also select the automatic labeling option there. Once that's done, we will see on the surface that the pictures of our shoe appeared, and it is ready to be labeled. So let's select all the 24 pictures and click on Draw Boundary Boxes. If we did that, we will see AWS's surface to draw these boundary boxes. Let's do it for all the 24 pictures, and we should be in a position where we have all the pictures labeled as expected. So just a quick recap. We uploaded our data to AWS using the AWS console. We stored this data in a service called Amazon S3, and then we referred to this S3 bucket from Amazon Recognition Custom Label, and we did the labeling. So now we have a data set that is ready to be used for machine learning training. So what's next? On AWS, there are 2 reasonable choices now. So if we are machine learning experts, but we still don't really want to deeply understand how to provision AWS infrastructure or how the AWS resource elements connect to each other, we can go with AWS's flagship machine learning service called SageMaker. SageMaker is optimized for all the major machine learning frameworks such as PyTorch, TensorFlow, Apache MXNet, and so on. And it also is very well integrated with other AWS services like Kinesis video stream that I mentioned before, or such as Amazon S3. Or if we are lucky enough that there is an off-shelf solution for our problem in the AWS high-level machine learning service portfolio, then we can go with that. That means we don't really need to be machine learning experts or data scientists to use machine learning to solve our problem. We don't really need to deeply understand how a neural network works. And sometimes we don't even need to write a massive amount of code, but we can still achieve good results. So thankfully, for our problem, there is a high-level machine learning service. This is called Amazon Recognition. I might have hinted about this in the previous steps. But just a generic overview, Amazon Recognition is a video and image analysis service that has quite a few built-in models to recognize objects on pictures or videos, faces, for some reason celebrities, and text. So we can use it off-shelf. That means that we can just pass a picture, like, OK, dear Amazon Recognition, what is in this picture? And then it will return us the labels, the objects, which is pretty nice. Although, unfortunately, in our case, this is not sufficient. We have our own objects. AWS won't know about our own products. So we need to train our own machine learning model to recognize our own products. The good news is that Amazon Recognition has a service for that, or like a feature for that. That was the custom label generation that we used before. So to do so, we can go back to Amazon Recognition page, where we already created a project and uploaded our data set. And then we can create train a model. Once that's done, training job will be kicked off by AWS. Behind the scenes, AWS will spin up server clusters with GPU instances, select a variety of algorithms and hyperparameters for these algorithms, and start the training. And we will train multiple options or multiple models. And if we use our data set, more precisely a slice of our data set that we call test set, to test these models, and it will return for us the best performing model. And once that's happened, we will have this nice training completed status, and that means that we are in a position that we have a trained algorithm that we could use to recognize our products, or this, in our case, this particular product in a random picture. Now all we need to do is to deploy this model to production, just to enable us to do the label detection. So thankfully, it's also pretty simple with Amazon Recognition. We can just simply select the model that we want to use, and click on Use Model, and then click on Start. So that will spin up another cluster for us, but in this case, this is for recognition to run the model, and AWS will deploy a trained model to this cluster, and it is ready to be used for image recognition. And we can then use this infrastructure or this cluster to recognize products on our test images. So what I did here is that I created another bucket called Snapshoes test, and took some pictures of this pair of shoes and with my phone, and uploaded it to this bucket. And then I used AWS command line interface, or AWS CLI, to detect custom labels on on these pictures. Now, I could have used a base64 encoded version of this image. I just wanted to keep it simple for now. And as you can see on the bottom, the result is basically a list of labels with some confidence and with the coordinates of the boundary boxes. So I did it with a couple of pictures. As you can see, I only uploaded 24 pictures and spent 55 minutes on training. But as you can see, it kind of found the right rectangles on these like random pictures, which I think is a pretty decent outcome. Just to sum it up, what happened here. So we defined a business problem and that we wanted to solve with machine learning. And then we walked through the whole machine learning workflow. So we collected the data, we uploaded the data to AWS and stored this data, and then did the labeling and as the feature engineering step. And so we prepared this data for training. We picked one of AWS's high-level machine learning services, Amazon Recognition, then to train our own machine learning model. And then we also asked Amazon Recognition to deploy this model to a production-like environment. So we could then access it via the AWS CLI. We could have used AWS SDK as well to detect labels on our own pictures. What we experienced for the whole journey, that for each and every challenge, there was an AWS service that actually did the heavy lifting for us, so we could focus on the problem, and a bit more importantly, we could have some fun. So thank you for your attention.
Thank you for the presentation, and we have some questions. The first one is, how mainstream is the use of the AI in this segment nowadays, and how is it going to change in the future?
In segment, what do you mean? Is it like image recognition?
I think yes.
Well, yes, I think it's quite common nowadays to use AI for image recognition. Let's just think on the self-driving cars or like on the social media, and we want to do face detection. So it's quite common, especially that now we have tools like this that, I don't know, for an hour of effort, we can have a basic model that actually works and that actually recognizes our own objects. So it's nowadays it can become mainstream because it is available for almost everybody.
And how is it going to change in the future?
I think we will just have more and more of this.
Yeah, okay, thank you. And the second question is, what kind of data set size would this approach be more economical as opposed to manual labeling? So
you mean like how many pictures do I need to have a decent solution, right? Yeah.
Yes.
Well, it depends. It depends on the quality of the images. It depends on what the expected outcome that we want. So I think 24 pictures is not too much, and that was all that I uploaded. So this model doesn't even know that there are other objects out there, other type of shoes. So the more is the better, usually.
Thank you, and thank you so much for the answers and the presentation as well.
Yeah, thank you very much.